Hi, our topic is malware analysis using behavior detection techniques. Malware is a software that is specially designed to disrupt, damage, or gain unauthorized access to a computer system. It could harm the user's device, change user data, and also use up bandwidth of the resources. How does malware detection work? Malware software can hide themselves or disable activity when they discover that an attempt is being made to detect them. This brings up the need for methods that analyze the system using trusted methods so that the malware does not detect them. A malware software needs to communicate with the initiator of the attack. Oftentimes, this communication happens over the internet using known protocols. The network traffic that is taking place over these protocols can be analyzed. There has been a lot of work done to train models to analyze network traffic for the detection of a malware. The landscape in the network security field keeps changing, with newer, safer algorithms being implemented, as well as malware adapting to better hide themselves from newer detection techniques. These previous works, while effective at the time of their publishing, might be outdated now. We make an attempt to recreate and compare such malware detection techniques to test their effectiveness and validity in the current day and age. Now, handing over to Samruddhi for their approaches.
Now let's look at the approach. I have borrowed the classification chart from our first meeting. The research problem involves working on a dynamic malware analysis, which essentially means setting up VM for analyzing the behavior, interaction, and effects of malware on the system, a behavior-based approach. Let's look at the implementation. Our implementation technique consists of a behavior-based techniques, which is achieved by executing malware, monitoring behavior of network, API files for operations and registry modification nodes. The file is downloaded from the internet, consists of API are application programming interfaces created by Windows to interact with kernel system. The two APIs, that is the Windows API, dynamic library link with standard predefined functions, and network API, will be used for developing detection models. So you can see there are two behavior-based trained model. For the first technique, we'll be using Cuckoo Sandbox. And for the second technique, we'll be using a network analyzer Wireshark, which will be used for traffic analysis, protocol, packet analysis, eavesdropping, etc. Now let's look at the results by Tanvi.
After conducting our experiment using the network techniques defined above, I will now talk how we will evaluate our experiment. For that, we have defined ground truth parameters called the confusion matrix. These parameters are two positives, that is to correctly identify the malware samples, two negatives, that is to correctly identify the clean samples, and similarly, we'll be taking out the false positives and false negatives. Using this, we introduce a certain criteria like sensitivity, specificity, and accuracy. Sensitivity is defined as the percentage to correctly identify the malware samples. Specificity is the percentage of clean samples that are correctly identified. Accuracy is defined as the overall percentage to identify clean and malicious samples. This will help us to compare the techniques and find the better technique. Thank you for any questions, please free to email us or drop a comment below.